Thank you for joining today's discussion. I'm Danielle Shimoni, and I will serve as your moderator for this webinar. In keeping with standard practice, all participant lines are muted. Please enter your questions in the question box at any time. We will address all submitted questions at the end of the presentation. All webinar registrants will receive a follow-up email, including information on how to access a recorded version of this webinar. Today's topic is Manageable Zero Trust for OT Networks, presented by Dr. Jacob Benjamin and Blase Janov. Jacob Benjamin is the Director of Professional Services at the industrial cybersecurity company Dragos. Before joining Dragos, Dr. Benjamin was a nuclear cybersecurity researcher at the Idaho National Laboratory. Jacob has substantial cybersecurity experience with operational technology at domestic and international critical infrastructures. Also joining us is Blase Janov. He is the Director of Business Development at Waterfall Security Solutions. He works with Waterfall's technology and channel partners to implement advanced joint solutions to meet today's evolving operation cybersecurity challenges. Blase also worked as a direct consultant in several technology industries and holds a Bachelor of Science degree from Indiana University of Pennsylvania. And now, after the introduction is complete, I turn the webinar over to you, Blase and Jacob.
Okay, thank you, Danielle. Welcome everybody to this webinar that is between Waterfall Security Solutions and Dragos and our joint solution for achieving manageable zero trust for OT networks as advertised. So one of the things that we want to cover today first is OT visibility, really identifying what's on your operational network and helping you to understand through that visibility what are your most critical zones. And then we're going to talk about thinking about those zones more to a zero trust level for OT networks, and we're going to expand upon that a bit in terms of what that means and how the joint solution advocates that. We're then going to talk about the required segmentation and monitoring that's required, as well as how the joint solution makes it all achievable. So go ahead, next slide, Jacob. So we're all aware of many of the challenges that you see here. The first is the OT IT convergence that's happening out there. We are all very well, I think, becoming more familiar with this being a trend in the market right now. It's bringing a lot of business and operational advantages, but at the same time, it's unfortunately growing the OT threat landscape. Compounding the issue is a lack of visibility. And this lack of visibility inhibits the ability to produce an accurate asset inventory and network map as well. And that's really where you begin to strategize on how you're going to understand your cyber and operational vulnerabilities. And it's a challenge when you don't have that starting point. We're going to talk about the fact that monitoring is required, especially safe monitoring due to the sensitivity of OT networks that is required. We're learning now that flat, unsegmented networks are something that's proving to be very vulnerable. And segmentation, much more granular segmentation is required. Now, mostly recommended, and adding this type of segmentation, though, has a very high impact of change on an organization and is very hard to manage as well. So we're going to be addressing how the joint solution addresses both of those aspects as well. Next slide. Okay, great. So we're going to take it and we're going to begin from the perspective of the joint solution itself, and then how the joint solution really addresses the challenges that we just went through. So we're going to begin talking about how the Dragos portion of the solution really addresses that visibility question, providing the visibility, the device locations, interactions, interdependencies, so that you can really begin to understand, where your critical zones are and what your critical assets are. And having the ability to understand those in a single pane of glass so that you can begin to identify those zero trust areas. So Jacob will be up first to speak about that. And then I'm going to come back in and talk about the hardware piece of it and talk about Waterfall and how we are enforcing the segmentation differently to make it more manageable, to reduce those areas from your attack surface, both micro-segmentation and broader segmentation depending on your particular architecture. And then we're going to talk about how we provide that segmentation in the most secure and maintenance-free manner, and how we really enforce zero trust by design or by default. And I'll elaborate on that when I get into that part. And then Jacob will come back in and he's going to talk about the monitoring that we mentioned that is required and how Dragos really provides that in a safe and effective way to protect against insider threat, for example. And then lastly, I'm going to come back in and kind of bring it home to talk about how Waterfall enables the Dragos solution, as well as pulls all other data requirements that are needed from a particular segmented area. So with that, I'm going to turn it over to Jacob to begin to talk about the first portion of this solution. And I'll let you go, Jacob. Thanks.
Thanks, Blase. Yeah, so one of the most common questions that we hear when talking to the community is about we've got several of them listed here. Needing to know what's on the network, looking to identify misconfigurations or security gaps, rogue devices, when assets change, being able to identify those changes and when they took place, as well as understanding what's happening within the protocols themselves. So these are all probably questions that you've run across as well. So many of you may already have a solution or a process in place to help you gain insight into your network or your asset inventory. A lot of times we run into scenarios where asset owners believe that their ICS network is segmented off from their corporate network. But when adding visibility, we end up finding rogue devices. Maybe it has connectivity, or there's remote connectivity setups for integrators or OEMs, which in many cases is okay, but it's really important to be aware of those connections and then to monitor them more closely. And so these questions are backed up by statistics and from several reports, specifically the year in review report that Dragos puts out every year, summarizing our threat intelligence as well as our service offerings, or lessons learned from our service engagements. And so last year, 81% of the organizations had limited or no visibility. So it really speaks to that point. And then, of course, our year in review for 2020 is coming out later this month. But this also goes hand in hand with the state of ICS or OT cybersecurity report that was put out by SANS that said 50% of asset owners are looking to implement asset identification and management. That's something, and 45% are looking to increase visibility into their control systems. And so we can talk about how the Dragos platform works for that. So we have a lot of visibility there with our sensors, and then specifically with the visibility into the ICS specific protocol. So we're looking in the deep packet inspection of DNP3, Modbus, TCP, and those kinds of protocols. And so I have a demo scenario that we used for a variety of reasons, so I'm going to walk through. And this is about how we can add visibility and asset identification, right? So we're going to take a little journey to CYBERVILLE. So at Dragos, we have several ICS ranges, and they run all sorts of equipment, and they cover different verticals. This particular range that I'm going to use to tell this story is filled with devices from Rockwell, SEL, Emerson, Schneider, and GE. And so CYBERVILLE is meant to be an electric range that simulates power generation, storage, and a substation. And so today we're going to focus on the CYBERVILLE Energy Center. So this specific center, just to kind of tell the story of it here, this one is a multi-purpose facility that contributes to a more resilient electric grid. Specifically, it provides energy storage, peak demand generation, and black start support. And so its energy storage systems, they play several roles within the grid connection, from load following to load smoothing to frequency regulation. And in the event of a serious blackout, the CYBERVILLE Energy Center also plays a startup role. And so it also has large-scale batteries that can be used to fire up a generator to restore grid operations without a power feed from the transmission network or backup source. And so this is one of our scenarios here. And this specific facility that we have mocked up in the range, it's representative of a small 44 megawatt gas turbine combined cycle power plant, as well as a 10 megawatt, 40 megawatt hour lithium ion battery storage system, and a 240 kV substation. And so just in NERC SIP speak there, the 240 kV transmission substation is a BES cyber system NERC SIP medium impact, and the battery and combined cycle generation are NERC SIP low impact. And so this is just a high-level overview of what the range looks like for this scenario. We have 3 different networks. We've got the battery network in the .10 range. We have the balance of plant in the .20 range, and we have our 240 kV substation in the .30 range. We also have our Dragos sensors in place, as well as the connection for our managed hunt service, which is Neighborhood Watch. Okay, so here is the first look at CYBERVILLE within the Dragos platform. So we have various parts of this network, we have them zoned out. And so this is one of the key aspects of using the platform for asset identification, is to be able to zone across an entire deployment and not just within an isolated area of the network. So we have sensors all over the various networks, and whether it's one plant or multi-plants or various tap points throughout the environment, we can see them all in one place, in one single pane of glass, as Blase said. So from here, we can zone based off IP space, types of assets, types of vendors that we see. But in this case, we have them zoned off by the actual plants, and then we have an additional zone for the historian. So the historian has connections to a lot of other places within the network at this energy facility, and we see this. Seeing this visualized helps me understand that it's a very important asset. So specifically when it comes to adversarial targeting, historians are they're potential pathways that an adversary could use to pivot all throughout the environment. So you can look here on the screen and you can see the communication that the historian is having with all the different networks that we have. Okay, so, and here we can see if we do have extra communications with our environment, and maybe in this case reaching out to the internet with the battery network, here we have it set up like an OEM or a vendor is communicating back, right? And so they might be doing that to perform updates or maintenance in the environment, but being able to highlight that and monitor that is very important for maintaining maintaining monitoring and maintaining the asset inventory. And then I'm going to elaborate on this internet zone that we have, and this is sort of a catch-all for any kind of traffic that's hitting IP addresses or points that are not considered within my network. And so this visualization is really helpful to me because it gives me that quick visual cue that to anything in my network that's talking to these endpoints. And we can zoom in even more here, and we can get a little more information about the specific protocols that are being spoken between these assets, right? And so it's important to be able to get different perspectives and different views of the assets, and not just by zoning like we're showing here, but being able to catalog and characterize what's in our environment. So we see the various protocols that they're communicating there. And so the Dragos platform can do this a variety of ways. So I've got a couple of things here. So here's a different transform of those networks. And so here you can see I've split it up by type of asset. So you can see I've got about 10 different PLCs in my environment. I have some virtual machines. I have some enterprise management servers, some Windows servers, and some controllers as well. And again, this is just a quick way to visualize my environment and help with asset inventory. This ability to visualize what's in my environment can help me understand what it looks like, and I can even infer the importance of various assets if it wasn't already directly clear, as well as help me identify rogue assets. And then I've got this great timeline feature which shows the assets and their communications based on time, and this really helps with the rogue asset identification as well as baselining. And so this is again just showing another transform of the visual of what you can do to the various lookout. The various views within the platform. With that, I'll turn it back over to Blase.
Hi, Jacob. If you could just go back to that previous slide, please, that'd be great. So as you can see, I mean, Dragos has an excellent tool to provide the type of mapping and information you really need to begin thinking about your network and thinking about, you know, what areas are most critical or what areas you may want to label to really be at a zero trust level of security. This kind of really opens up that visibility and gives you the opportunity to do that and begin to make those decisions. Now that's where we're going to take an example, as Jacob brought up the historian. That's an excellent example. You can see from this map that he developed initially, that historian right now has obviously a connection directly into the production network, as well as connections to the battery network and the office site network. So there's external exposure there. Next slide, please, Jacob. So there is external exposure there, you know, through the historian, which is a very important asset as we've identified it through the previous slides. But unfortunately, you know, the historian can be used as a pivot point to get into the control system in the way that it is set up right now. We all know how a lot of these attacks work. They'll steal passwords. They'll compromise one machine remotely to gather information for credentials for the next steps and then continue on from there. And this is a good example, a good linear example of how that can happen, you know, within a typical type of architecture that we'll see in plants like this, where you have the enterprise network, the DMZ, and then the operational technology network. This is something that, as I said, is a little bit more familiar, a little bit more traditional, but we know from a lot of the current news reports that this is something that does get compromised, and it can definitely pivot through the historian to do so. So next slide, Jacob. So we're going to talk about, you know, an alternative to being able to provide the segmentation that does not have that vulnerability by default. You know, one of the definitions that's uniform about zero trust is that it's the philosophy that you're really not trusting any of your security protocols or your network itself by default to protect a particular area. That something needs to be added, something else needs to be addressed in terms of workflows or additional layers of security to really be able to ensure that that area is zero trust and that it can't be penetrated. What I'm going to review here with the Waterfall Unidirectional Security Gateway, this product enforces zero trust. Unlike other technologies, it does enforce it by default. And so what it will do with a hardware enforced barrier is it physically prevents any external attack from traversing from one side to the other. In this case, to get from the external network through the historian and into the OT network. And since we were talking specifically about a historian, I'm going to use that as an example of how our technology works, you know, for this particular use case. Now, we can emulate devices via the protocols that they communicate in, and we can also replicate entire servers, in which case we'll be talking about today because we just talked about the historian. So if you take a look at the solution, that we have, everything that's here in the red box makes up the total Waterfall solution. So on the left-hand side here, you have the industrial system. And you can see where the historian is represented there, that's directly connected to the industrial network, just as it was on the previous drawing. Now, what we do is our solution is made up of 2 parts hardware and 2 parts software, with one side being a gather and send side, and the other side being a receive and publish side. And the way that the total solution will work in the example of providing a historian replica, which I'll explain in the next slide, in order to create that as a zero trust area and not allow any external penetration to attack it, what we will do is we will initially act as a client with our first host here that you see to the far left. That will actually act as a client and gather all the information that we require initially to send over to create the replica. From there, that's where our first piece of software actually goes to work. And what it does is it removes the header information, anything that's routable, and really replaces it temporarily with our information. And you really just have like frame data at this point that's at this stage of the solution. From there, it moves on to the first piece of the hardware enforced element of the solution, and that is the TX module. And that module is actually hardwired to only be able to send information. It cannot receive. It just has a laser cell that enables it to send, no photo cell. So what it does is it sends that information across this fiber optic cable here. Once it reaches the RX module, again, that is the opposite functionality, so that it can receive, but it can't send. So it has a photocell, no laser, to be able to send. So once it receives it, it moves it on to the second host. And by the way, these hosts can be ours that we provide, or they can be your hosts within this total solution. But in any respect, what we'll do with this host here is we put everything back together. The software goes to work to put everything back together in its native format. And then from there, it is pushed out to produce a fully replica historian. So say, for example, that historian is a particular make, say, OSI soft Pi. We would be communicating in native Pi data as we produce this replica, so that it is seamless and it is in real time. If it's a GE historian, for example, same thing. We're going to be communicating in the protocols that are native to that particular historian, and that is pushed out to create the replica. Now from there, if there is any attack that comes in from some of the exposed areas that we showed before, they cannot penetrate this barrier because it is hardwired unidirectional, as we're showing here, and it is completely hardware enforced. So by default, it will enforce zero trust, because as we talked about, one of the principles of zero trust is you're not relying on your security tools. You're not relying on hardware. You're not relying on your network to protect you, because what it's saying is by default, it doesn't have the ability to do that. Our product does by design. Next slide, please, Jacob. So going back to the original OT map that we looked at, that Jacob pulled up initially, now we're showing, after we explained how our technology works, now you can see how we've addressed this historian and utilized our solution to segment it to a zero trust level. So before, you had the correct connection going, right into the production network. And then you also had the connections to the battery network and the site network, which were obviously clear attack vectors through the historian into the production network. But now, because we have utilized the gateway to create the replica, now the replica is working as it normally would if it were the original. The only difference is these external networks now, the site office network and the battery network, are communicating with the replica safely. So there's no way, being that we have our hardware enforced barrier here, there's no way there's going to be any external penetration that's going to come through to the original historian and get into that production network. It's now stopped cold right here with our hardware enforcement, and now you have an historian that is working seamlessly as it needs to, but now it's locked down to a zero trust level of security in terms of external penetration. Next slide. So going back to the original state that Jacob originally reviewed here, as you can see, there are firewalls here, and by the definition that we're talking about in terms of zero trust, this is not, you do not have the ability to rely solely on the network or solely on the security tools like firewalls, for example, to enforce that zero trust level around that historian or the rest of the plant underneath it, for that matter. Something, as I said, has to be added. There has to be other workflows, other protocols, something else has to be done to bring it to that level. Next slide, Jacob. But when you enter now the Waterfall device, now you do have that by default. You do have zero trust by default through the hardware enforcement. So by us coming up through the historian now, we are giving the data, feeding the data as it was normally going to the corporate network. Those communications remain intact. The communication to the battery network remains intact, as well as pushing the data that's required for the Dragos sensor. But now, instead of that historian being an attack vector, it's actually the point in where zero trust is established, not only for that historian, but also the network that we're protecting underneath it. So what I'm going to talk about next is how we use software to really achieve, what you're seeing here. I'm going to dig a little bit more into the software elements of what we provide that really is truly the secret sauce that makes this all possible. I'm going to talk about how we feed the Dragos sensor first, and then how we feed these other 2 points through software. Next slide, Jacob, please. So one of the ways that we will feed the Dragos sensor is their sensors have the ability to ingest in span port. So at that network layer, we will actually, through our software, be able to feed that Dragos sensor via span port. That does two things. It locks down that area, still to a zero trust level, but by being able to feed the sensor to that particular enclave, all of the monitoring and all the other benefits that Jacob's going to talk about further on in the presentation that Dragos offers, things to protect against insider threat, for example, operational vulnerabilities and misconfigurations, all of that is still taking place in the segmented area, being the fact that we are feeding the sensor as if we weren't there. So in this case, we're more emulating devices rather than replicating a server like we did in the historian example. Next slide. So once we've done that, once we've replicated, if you go back to that other drawing in your mind, you can see where, we were going to the sensor first, but then we were, going through the historian to replicate that. So you can see up top where you have the historian, obviously we'll be able to provide the data that's necessary to feed that functionality, and really any other type of data, whether it be data that's required for the SCADA system, workstations, HMIs, all that data will be able to continue to feed out at the application level as required from the segmented area to make this solution as seamless as possible. And that's really the main point here. You're not sacrificing, with the hardware barrier there, you're not sacrificing the ability to continue to read and pull out the data that you needed from your segmented area as the solution continues on. So go ahead, next slide, Jacob. So this is just an example of what I'm talking about in terms of the software that we use. This is just a very small, really sampling of all the software that we have. But you can see, like in our example case here, there are many different types of historians that we can replicate. We can also move data via files. We can move data via industrial applications and protocols, all those that you see there and more. And then we even have the ability to provide remote access to different areas, just as the battery network required. Don't have enough time to talk about that in this webinar, but that's another example of how we can even lock down a network like this even further through being able to provide that kind of functionality. Go ahead, next slide. So just very quickly, we have over 1,000 deployments right now worldwide. And these are all of the certifications, both on a national and international level that we have. So the use case that we're describing here and the functionality that we're stating is very well proven. So go ahead, Jacob, for the next slide, please. So one thing I wanted to just mention in passing as we're kind of bringing this home a little bit, I'm going to be turning it over to Jacob to talk a little bit more about his monitoring capability and, as I said, how we're enabling that. But we only had time today to really go through one use case. So we took a power station and we went through it and we identified the historian as the zero trust zone, and we showed how we were going to address that. But there are, one of the takeaways that I hope that you all get from this is there are many, many applications for this joint solution between Dragos and Waterfall to be applied in many different types of environments, many different types of vertical markets, not just power. One example that I wanted to just throw in here to get you thinking in that direction is manufacturing. Manufacturing is, if I had to think of another vertical, it's very, very dynamic in terms of the environments, a lot of connectivity, a lot of decentralized control. So you might be, just to give a couple of examples, you might be looking at a major discrete set of production lines for a manufacturer that makes many different types of products and has many different production lines with intellectual property and crown jewels that are really centered around those production lines. Those are excellent applications for this type of technology to create those areas of zero trust and really lock those down, particularly in the vulnerabilities that you have within manufacturing. Another might be CNC manufacturing, something as different as that. A lot of the controls are handled right on board in a CNC machine, but just like a major power network, they're looking to share their data up to their management as well. But they don't want to allow, attacks into the intellectual property and into the proprietary designs and everything that they're building in terms of their parts. that is another excellent example where this technology can be used to segment. So this is a perspective rather that's been done by Dragos. And I think it's excellent. I recommend you all check it out. And I think that that can give you some other ideas, not only talking about some of the challenges in manufacturing, but where some of this zero trust applies to the joint solution. So go ahead, next slide, Jacob. So just to summarize, and then before we finish off, Jacob's going to talk a little bit about just the validation of the joint solution up next. But just to quickly summarize, you know, what we've clarified here very clearly is, you know, at the end of the day, when the joint solution has been fully deployed the way that we've described, you've got operational control workflows and key interdependencies are clarified. The critical assets and operations are better identified and better understood. You know, the critical areas and hardware enforced segmentation are enforced to a zero trust level to prevent both cyber attacks and operational errors. And the entire OT network, including the segmented areas, continue to function normally. And the joint solution is passive and non-disruptive, and it's low maintenance. Go ahead, Jacob.
Thanks, Blase. And I think this one's me. So,
yep.
As Blase mentioned, with the threat perspective for manufacturing, we do those for a variety of different verticals, and I definitely encourage you to look for those, as well as our upcoming year in review report for insights on our service engagements in 2020, as well as our intelligence bulletins. So as far as the Dragos platform, today we've really only focused on the visualization and asset identification, and those are really just a few of the features of the platform. Our main focus has always been threat detection itself, right? And so we have found that most companies that are looking for asset visibility and wanting to understand their network, you know, that's great. They'll put a solution in, and then 6 months to a year later, they want to move on to wanting to understand not just what's there, but what's changing. We hear things like, I want to focus on the right things and not get lost in the noise. How can I go about finding context there? And the way that the Dragos platform provides context is through these threat detections and threat notifications. And these are informed from our services team and our threat intelligence team, and to really add value there. And specifically for validating this joint solution is so once you put in place the Waterfall solution, the Dragos solution can help make, you know, it will validate that, yeah, those communications are being dropped appropriately. There isn't any more direct connections between those insecure networks. And so with that, I think we get to the Q&A portion, and I'll turn it back to Blase.
Okay. Thanks. So if there are any questions, you know, we're happy to answer them now. Andrew, what do we have in the queue?
Oh, Daniela's got the queue. Daniela, can you read the first question, please?
Yes, hi. So the first question that we have is for Jacob. Is the platform from ICSIOT visibility in line with the cybersecurity zones used for the segmentation?
Yes, yeah. I mean, yeah, it is. And so usually the sensors are as close to the OT devices as possible. We are able to do place sensors very close to the devices, as well as on the far side of the Waterfall solution, and we're sending the alerts and notifications out. We can do it both ways. We do prefer to be as close to the devices as possible, lower in the levels. So if you're the Purdue model, you know, lower to the level 1s, or if you're the NRC model, then the level 4. So yes, we are in line with the different models.
Thank you, Jacob. The next question is for Blase. How do you update your industrial systems? Where do the binaries come from?
Take that one, Blase, if you want.
Yeah, go ahead.
There's a variety of ways to go about it, and it depends upon your risk appetite and your regulatory environment in general, right? So it's going to be very different for a nuclear plant compared to a manufacturing facility. And so there's many best practices. At the very least, I would consider testing your updates and things on a replicated system, like a test system, before pushing to your production system. A lot of folks use kiosk and things like that to validate the updates and then push them that way. There are solutions you can do through a demilitarized zone before going through there's a variety of ways to do it, but it really depends on your regulatory environment and your risk appetite.
Thank you, Jacob.
Yeah, and
Yes.
thanks, Jacob. And Andrew, since you chimed in there, I maybe interpreted that question a little bit differently in terms of how are updates, happening underneath Waterfall, or is that, maybe am I misinterpreting?
No, this is Andrew Ginter. I want to echo what Jacob has said. I agree with everything he said, but let me go just one level deeper. What would the average power plant, when we have security updates come through, when Microsoft issues a security update, are the machines on the control system network set to automatically update? Not a chance. Not a chance. Even in a robotic manufacturing environment where you have people crawling into machines, technicians crawling into machines to repair those machines, the software on those machines has to be certified for safety. There's no way you're going to, enable automatic updates. What are we going to do when we have a security update or a software update that we want to apply? Just like Jacob said, it depends on the plant. But what we see a lot of people doing is they will take that update, drop it on a USB drive, carry it physically into an isolated test bed, test it, typically for months before they believe it, before they trust it, and then carry it into a WSUS server inside the control system and use the WSUS server to manage the rollout of the security update, to the least consequential machines first, then to machines that have redundance, so you can apply the security update on one, start using it, see if it works. If there's any trouble, fail back to the other one that does not yet have the update, roll back the update. There's a whole process for most sites. But to Jacob's point, other sites are less critical. If you have a site where occasional downtime is not a big deal for whatever reason, you might enable automatic updates, and if there's a problem, well, take everything down for 3 hours while you restore from backups. It depends on the criticality of the site, but most sites use a test bed for quite a length of time before the engineering team trusts the security update.
Thank you, Andrew, also for answering. We'll go to our next question. What kind of threat intelligence helps offer less noise a year down the line of using the log monitoring?
Yeah, you're asking for a specific threat intelligence. I mean, it's going to be it's making sure that you're getting the correct sources. So making sure you're getting threat intelligence that is relevant to your vertical and to the types of systems that you have. And then once you do that, it's really important to configure your detections, and the Dragos platform does a really good job of having those detections configured and playbooks linked and things like that give you that context around it. And so we develop resilient detections that are not just based on IP addresses or hash values. They're based on threat behaviors. And so that allows them to be resilient even after 6 months to a year, versus something where the adversary can just simply change a small part of their infrastructure and keep going with their attack. And so that is one aspect of how we use threat intelligence to do resilient detections that are withstanding for longer periods of time.
Thank you, Jacob. We'll go over to our next question. If the Waterfall solution makes sure there is only unidirectional traffic, how can you interact with the system behind it? You can't send any commands, right? Thank you in advance.
Yes, I can. I'll address that, and
Yes.
you're happy to chime in with me, Andrew. Yeah, I mean, that is a common question that we do get. So, every architecture is a little bit different. We obviously want to be placed to where we are not interrupting control. A couple examples I gave in manufacturing, for example, around a particular production line or around a CNC machine network are examples of that. Depending on the protocols that are required, the applications that are required, and depending on the amount of control that needs to come in and out of the enclave, we do have architectures that allow for that by using another gateway. That's something that we'd be happy to discuss further with you for your particular architecture. Ideally, we want to be placed in such that we're segmenting that we're we are not interrupting control, but if control is required, that's something that we do have the ability to do. Do you want to add anything to that, Andrew? Yes, no?
Yes, so let me add to that. The most common, by far, the most common messaging that goes into an industrial network or into a DMZ is a request to go into whatever systems are configured as the IT/OT interface. In this example, most often it's a historian. And so you need to send queries, questions into the historian to get the answers back out. And how can you do that if there's a gateway in the way? And the answer is you don't. You send the question into the replica, into the enterprise historian. You have all of the power of the enterprise historian. That historian has all of the data in it that anyone is allowed to share with the enterprise. All of the data is there. So, analyze it, summarize it, do what we want with it. If we're talking about controlling the industrial process from, a machine on the internet, how many machines on the internet are authorized to control the industrial process? How many machines on the enterprise network are authorized to control the industrial process? Almost none, usually none. If you do have a need for that kind of control, you need the very highest kind of security in place for that, because the enterprise network is compromised much more routinely than the industrial network, and the internet is the source of all compromise. So the short answer is that you interact with the replica, and if you need something to go in, well, talk to one of our experts. There's ways to do it. They're complicated, but that's arguably the right answer. You don't want it to be easy to control the industrial process from the internet or from anywhere else.
Thank you, Andrew. Our next question, what is the overhead of the combined solution on an OT network that in many cases must maintain real-time or near real-time response time?
I'll take a quick crack at that because my answer is much easier than Blaze's answer. My answer is there is no real overhead for the Dragos solution. It's a passive monitoring, so it's sensors just listen on the wire. So it might be through span ports or it might be through replicators or things like that. But it will not interfere with that that issue. But I'll let Blaze speak to his part of the solution.
Yeah, and we're talking, just to be clear, we're talking about the management function, management overhead of our device. Did I understand that correctly, Jacob? You think?
Yeah, I thought it was from a technical standpoint, not a financial standpoint.
Okay, no, that's what I got as well. Okay, yeah, that's a very good question, and I'm glad you asked it because that's something that hopefully I emphasized well enough in the webinar itself, and that is that really once Waterfall is configured, we have much less impact of change in a particular environment because we're not a firewall. I don't want to say it's a set it and forget it solution, but it's much more close to that than any other type of solution that you would deploy to create segmentation in the way that we're depicting here. As compared to a firewall where you have a lot to manage, you have a lot of configuration changes to keep up with, and especially when you're considering zero trust, there's even that much more interaction that has to happen and maintenance and configuration that has to happen with that firewall. None of that exists with us. So not only are we more secure to provide that level of segmentation, but we also have much less impact of change from a regulatory standpoint, for example, and from a technical management standpoint. There's just much less to manage there, which is another thing that makes it an excellent solution for this. Hopefully that answers your question.
Thank you. Next question. Does the solution allow to use offline sensors, or they need to be 24/7 connected? We do have an island network which are completely air-gapped.
Yeah, I think we can both take that, Jacob. Do you want to speak from your side first, and then I can?
Yeah. So it is always our preference to work with live data. We do have support and integration for PCAP ingest and things of that nature. But I would certainly advocate for live data. Even on an air gap network, you could you could passively monitor that. So I'll let Blase go.
Yeah, and thanks, Jacob. And that's where the two solutions really work well together, because through our software and the fact that we're dealing in the native applications, we are able to maintain an air gap level of security, but still feed the data that you require in real time. That includes the data that we're feeding Dragos to the sensor so that they can do exactly what Jacob described. And that's so everything else, like the data that's going to the historian or any other type of protocol or native applications that need to come out from, say, OT to IT, we're providing that in real time, while at the same time, because of the hardware enforced barrier, you're still retaining that air gap level of security. And that's one of our biggest features and advantages and selling points.
Thank you both. Next question. How frequently are data updated on the other side of the appliance? Example, historian.
I think that one is specific to you, Blase. Sorry.
Yeah, I know. I think this is the question that I was hearing earlier in terms of keeping the replica, if I'm understanding it correctly, keeping the replica and the original historian in sync or updated. If I'm interpreting that correctly, Andrew's gonna be better. He'll do a better job than I can to answer that one, but I want to make sure that I've got the question correct. What do you think, Andrew?
Yeah, I think that's the right question.
Yeah.
You know, there's two answers. The general answer is, what do you need? You know, each of our software connectors has a certain, you know, rate of update. Polled connectors, where you have to issue, you know, like Modbus, issue a poll request and get an answer. You know, you are limited by the rate that you configure the polling. Event-driven connectors like Oracle and SQL Server and Pi and iHistorian tend to be in the 100 to 150 millisecond range, depending on the load on the databases, because they are databases. The outside database has, you know, as many as 1,000 users connecting to it. And you know, the question is, how quickly can you update stuff in that database? But there's another answer, and the answer is, you know, it's as often as you need. When customers come to us and say, you know, your connector is not working for me because of X, I need 83 milliseconds instead of 107, we fix it. It becomes part of the standard product. This is how the product evolves. If you need something, just ask.
Thanks, Andrew.
Thank you. And next question will be for Jacob. How is the information obtained from DPI of ICS protocols used?
I'm not exactly sure. Wait, what is the question asking?
How is the information obtained from DPI of ICS protocols used?
Oh, deep packet inspection. Sorry, DPI. Yes. So we have a variety of protocol dissectors that we use to strip away the layers of the protocol to get to the actual commands. We have a variety of those, as well as ones that are publicly available, and so we can see the actual set points and things like that changed in the commands. I believe that's what you're asking. So it's just part of how our sensors work and the dissectors that we have connected to the protocol dissectors.
Thank you. Let's go to our next question. Are you also monitoring the application logic in terms of understanding if a given command corresponds to other commands sent in the network?
We have that capability, Dragos does, and some of it requires baselining and some of it does not. We do have custom QFDs, we call that, relate to various commands. You know, if you see this command, you expect to see others. If you see it with, you know, command 1, 2, and 3, then that may be indicative of an attack versus a normal command shift. So there are a variety of those that we do have in place. So yeah, that's all part of that resilient detections that we build up, understanding what a normal command looks like.
Thank you, Jacob. Our next question is, regarding the interaction in light of control, our project seeks to remotely control a manufacturing process that lies within the highest security zone. Do you have a suggestion or solution regarding this architecture? Our security team advised against it, but the business wants it.
I will let Blase take a lot of that, but I would certainly, I'm more inclined to side with your security team, honestly. I don't, especially if you're going to call something a critical process, I would hesitate at any kind of remote control for that. But that doesn't mean it's impossible. It doesn't mean there's not a secure way of doing it. I do think this joint solution possibly enters a secure solution for that environment. I know Blase has some interesting ways that they handle control, and I'll let him talk to that.
Yeah, thanks, Jacob. But, it kind of goes back to, that was a similar question earlier, and I couldn't agree more, and I'm sure Andrew would concur. The first question we're going to ask is, why on the remote control? I mean, so I definitely agree with your security team. A lot of times what we'll do is we'll look at the particular architecture and really take a close look at what's being asked and try and reduce the remote requirement down to an absolute minimum. In other words, get everything we can off the firewall and onto our product so that we're protecting mostly everything we can. And then from there, if control is still required, as I said, we do have ways that we can enable that. I don't know how much you want me to get into that, Andrew, for the purposes of this, or maybe just hate to beg the question, but I'd say we could explain that, a little bit more detail offline once we understand the requirements. We can do it, but we'd want to keep that to an absolute minimum, and we have ways of doing it. Anything you want to add?
No, let me just give you an example. A common request we get is central engineering teams, where the engineering team wants to remote control, as many as 100 plants continuously. It's possible, it's tricky, but one step in the solution is to make sure that the plants, the most critical networks in the plants are linked to each other or to the remote control station through leased communication capacity, not through the internet, not routed through the IT network. Its own leased, in the old days, T1, T4 lines, nowadays MPLS lines, or even 5G reserved, sub networks that are not routable to the internet. Like I said, it gets complicated, but it's possible to do. Your security team's right. It's going to be tricky to get right security-wise, and it's something that is worth sitting down with an expert and getting a couple of options and understanding costs and benefits and risks of each of the solutions.
Thank you, Andrew. I think the next question is for both of you. Is the Waterfall solution also visible in Dragos devices topology? And how do you manage updates and patches?
So any device that's communicating on the network is going to show up in the Dragos platform. I will let Blase speak to how updates to the Waterfall device works.
Yeah, I got another slide that I could show here, but I'm not sure whether Jacob has it or not because of the technical errors up front. I apologize for, but yes, we do have a product that's specifically designed for that. It's called Waterfall Flip. And it is just an add-on to our product that enables you to flip the direction of the unidirectional gateway flow temporarily, either on a schedule key or manually. And it's done for a very specific, very known scheduled period of time in which you can send in patches, antivirus updates, and then once that's complete, it flips back into the other direction and you're back up to unidirectional. Now, just because it flips one way and then flips back the other way, it is not completing a communication handshake, but it is enabling you to get those updates in. So we do have a product that's designed specifically for that, and we sell a lot of them, just for that purpose.
Thank you. Our next question. Regarding the unidirectional gateway, we use a data diode in our solution. How do you address the problem that occurs with protocols that require verification that the data is sent, such as TCP?
Okay, Andrew, I'm going to let you handle that one, if you wouldn't mind.
Sure thing. People look at a firewall. What does a firewall do? It forwards network messages from one network to another. It filters the messages. It says, is this message allowed? It asks that question for every message, and if the message is not allowed, it throws it out. That's a router. Okay, all firewalls are routers. They forward messages. The gateway is not a router. Unidirectional gateways, on one side, in the example we gave here was OSI Soft Pi. On one side, the gateway is a client of the OSI Soft Pi server. We send small questions into Pi saying, what's all the latest data? And we get very large responses. We build up a snapshot of the response, all of the changed tags and values. We send that snapshot through the strange one-way hardware using our proprietary protocols. And on the other side, the software is a client of the enterprise historian. And so, the software connects to the historian with a different TCP connection, a different encryption key, and sends very large commands, update all of this data, and gets very small answers back. Yes, that worked. Yes, that worked. And so these are completely different conversations on either side. There's a TCP connection between the gateway and the source historian. There's a different TCP connection between the gateway and the destination historian, and none of the messages are sent from one to the other. They're two completely different conversations. One is query response, the other is update response, different encryption keys. So, the short answer is we don't forward TCP messages through the gateway. We gather data on one side, we send snapshots of state through the hardware, and on the other side, we publish that data in whatever mechanism makes sense, in this case, by inserting it into a replica historian. Completely different conversations. There's no need to forward TCP and scratch your head how to do acknowledgements. The question just does not arise in the course of a normal gateway deployment.
Thank you. Let's go to the next question. How do you push updates with a unidirectional gateway?
I think we've handled this a couple of ways. You can do it manually going into a test bed. You can have a flip configured to, the flip is used more often, not so much for security updates because they need to be tested for so very long, but it is used routinely for things like antivirus signature updates. So the point is that Waterfall has a whole family of products. The unidirectional gateways are one way out, nothing back. End of story. Make copies of servers. The flip is a different kind of product. It is a kind of unidirectional gateway, but it's different from the main gateway. The flip, as you said, Blase, can reverse, and you typically configure it to reverse, I don't know, twice a day. And when it reverses, to your point, we're not, trying to forward TCP traffic. When it reverses, it replicates a different server. In this example, it would replicate the antivirus server, the enterprise antivirus server, into the plant antivirus server so that the two are synchronized and the plant has all of the latest antivirus signatures, and the plant can then coordinate rolling those signatures out into the systems in the plant. And there's other products in the family, but those are the ones that are relevant to sort of the scheduled updates.
Thanks, Andrew. I figured I'd let you give your version of flip this time. So thank you. It's a little more detailed than mine.
Thank you, Andrew. I have another question. It's for you both to answer. You can decide. When deployed together, which side of the gateway does the platform have to be deployed on?
So it doesn't have to be deployed on any one side. We have a preference to have sensors as close to the actual equipment as possible, and then maybe the site store is on the far side of the diode. That's the preferred. But we are able to do it where the entire Dragos solution is on the less secure side of the diode. We have both deployment options available.
Yes, and I concur. Absolutely, Waterfall can support either one of those preferred architectures as we integrate with Dragos.
Thank you. Next question is for you, Blase. Are you suggesting that we remove all firewalls from our OT network?
No, absolutely not. I mean, that's where we're getting into the question of identifying where your crown jewels are, the most critical areas or critical enclaves within your OT network, and looking to place the gateways logically there, just like we did in the case of the historian. Especially in manufacturing and other industries, you know, we do know that firewalls are, you know, kind of a necessary way of life. In these particular environments, and yeah, we can coexist, locking down your most critical areas as zero trust and allowing the other firewalls to continue to operate.
Thank you, Blase. Next question, how would we be able to allow OEM access to zones protected by your unidirectional solution?
Yes. Yeah, again, one of the things that we didn't review today that we have the capability, and it was on that list, I think I referred to it briefly, and that was our remote screen access. So we actually have a couple of different ways that we can enable safe access, like an example in the battery network. You know, rather than allow the OEM to come in through a VPN or a firewall and have bidirectional communication, what we can actually do is use another piece of software off our software stack called Remote Screen View. And what that basically does is replicate out the necessary screenshots that your OEM engineer needs to see to understand what's happening. And it really works like an over-the-shoulder phone support where you have one of your engineers that are sitting there doing the pointing, doing the clicking, you know, officially able to input the control commands by an internal employee, working over the phone with the OEM who's seeing everything in the form of screenshots. If it becomes absolutely necessary, like an emergency break glass situation where you have to have bidirectional communication, we have a product called Secure Bypass. It works, it's an add-on, just like the Flip product, but it's not the same thing, but it is an add-on product where you would actually turn a key that would disconnect the gateway temporarily. Then you would run, you know, through a firewall or through other secondary security, allow that bidirectional communication to happen during that emergency situation, and then shut it back down to go back to unidirectional communication after that. Most of our customers, unless it is an emergency where they need to use Secure Bypass, our Remote Screen View suffices just fine to provide the OEM support that's necessary.
Great. Jacob, the next question is for you. We're currently only using manual methods to keep track of our inventory. What is the first step to automate our inventory and further gain asset visibility?
Yeah, so there's a variety of options available to you. So as you start to do less manual methods and do more automated, there are some free tools out there that you can use to start to combine them to pull logs and things like that. Some use WMI, some don't. So you can start to use some of those as you gain more and more visibility. A lot of times we will see combinations of Dragos sensors in certain parts of the network and then log aggregators in certain parts, and then a combined solution with that as well, as we slowly get more and more visibility throughout the network.
Thank you. I have another question for you, Jacob. We're already using some vulnerability scanning tools. Why is that not enough?
Well, it's vulnerability is a very difficult topic with operational technology and ICS in general, right? And so for the most part, you do not want to just unleash a vulnerability scanner on your production network, right? That's just not going to happen. You need to have a test bed. You need to have those things going through. And that's one of the reasons that we're pushing forward with the passive vulnerability things coming in the next version of the Dragos platform. And so that's a big part of it, as well as just the visibility to see it. Yeah, because you can't use a lot of these traditional IT vulnerability scanners in the OT manner.
Thank you for that. So at this point, I want to thank you again, Blase and Benjamin. This was very great, enlightening, very informative, and also to thank you all for joining this webinar. As I've mentioned before, we will send a follow-up email to all registrants, including information on how to access the recorded version of this webinar for your review or to share with others, as well as registrant information for upcoming webinars. Also, we will follow up on all questions we did not get during this time frame. So again, thank you all for your time today, and most importantly, be well and stay safe. Blase and Jacob, do you want to add something to the end?
Go ahead, Jacob, if you wanted to add anything.
I just wanted to say thank you for the time, and I appreciate all the great questions and look forward to working with Waterfall on any joint solution deployments.
Yes, thanks, Jacob. And I mirror that. Thanks, Jacob, and thanks, Dragos, and also thanks everyone for attending. And again, those were all excellent questions. And hopefully, we've achieved our goal in getting you to think about your network. I can already tell that you're thinking the right way based on the questions. Hopefully, we address them, and we can get to the point where we would invite you to approach us as a team. We'd be more than happy to show you how this will work within your particular environment. So thanks again, everybody, so much.
Thank you, and I wish everybody a great day.